Yeah, so hello everyone. So this is a question from JEE Mains 2026-28 Jan evening. You can pause your screen and go through the question. So the question says the wavelength of photon A is 400 nanometer, okay? The frequency of another photon B is 10 to the power 16 second inverse, okay? The wave number of photon C is 10 to the power 4 centimeter inverse. The correct order of energy of these photons is, okay? So the chapters involved is atomic structure, okay? So we have three photons, A, B, and C. For A, the wavelength is given to us as 400 nanometer, and you can convert it into standard units, that is 10 power minus 9 meters. For B, the frequency is given to us as 10 to the power 16 second inverse, so already in standard state, no need to do anything. For C, the wave number is given to us, that is 10 to the power 4 centimeter inverse, or you can say by centimeter. So you can convert this into 10 power 4. We know 1 centimeter is 10 power minus 2 meter. So we can write it as 10 to the power 4, 4 plus 2, so 10 power 6 meter inverse. Okay, cool. And they're asking us to arrange these guys in the order of their energy. Okay, so either you can use the formula E is equal to h nu and can calculate for each one of them individually, but since this is JEE Mains, we have we don't have much time, so we'll try to do something. Okay, so let's talk about A. We know that in terms of wavelength, we can write this formula as E is equal to hc by lambda. Okay, so I will substitute this value here. So energy is hc by 400 into 10 to the power minus 9, or you can bring this 10 power 9 above, so it will become hc into 10 power 9 by 400, or approximately it is hc into 10 power 7 by 4. Okay, so that is the story of, so energy of A is approximately, it's around 10 power 7 hc. Okay, for B, energy will be, for B we know that energy is equal to h nu, and nu is given to us 10 power 16, so I can write it as h into 10 to the power 16. Now see, if you can see in A, I have a term called C. Okay, so I cannot compare it now. So to compare them, what I do is I multiply by C, I divide by C. Okay, C is the speed of light, and so we have this hc term. Separate this term out, so this is hc into 10 power 6, and write down the value of C, 3 into 10 power 8. So this is hc into 10 power 8 by 3. So now we can compare them. That is, for A it is hc into 10 power 7 by 4. For B it is hc into 10 power 8 by 3. Cool. For C, we again know that E is equal to h nu, but the wave number is given, so we can write it as hc by lambda. We know that wave number is equal to 1 by lambda. So this formula changes into hc lambda. So no need to do anything. We have this hc term already. Now, sorry, this is wave number. Yeah, this is wave number. Okay, so now wave number is given to us as 10 power 6 meter inverse, so I can write it as hc into 10 power 6. Okay, now we can compare. You can see that in the case of B, we have the powers around 10 power 8. In the case of A, the power is around 10 power 7, and in the case of C, the power is around 10 power 6. Why can we compare them? Because all three contain the term hc, hc, hc. So just you need to check these numbers, which of them is greater. So you can see in the B is the greatest because it is 10 power 8 by 3, so B maximum. Then A has 10 power 7 by 4, so then it will have A. And then you can see in the case of C, it is just 10 power 6, so it is BAC. So the energy of photon B is the greatest. Then we have photon A, then we have photon C. Yeah, thank you.